Alright, hey guys, so this is the iOS game programming workshop. Yeah, I'm Matthew. So a little background about me, third year CS. I started learning Swift this past summer, like through the Stanford 193 courses. So those are some very effective tutorials to start picking up Swift, as well as some other Udemy courses like Raw Crucible. And I have released an iOS game to the App Store called Keep Yuppie. So it's iOS development is a really fun concept. And yeah, I've been a video game fan since the age of 4. So why iOS game development? It's a very fun field because you actually get to put like the games you develop on your iPhone and iPad. You can also develop for the Mac operating system as well. There's some slight nuances, but overall it's very similar. You can make money on the App Store. So you can make money like through like a purchase fee, putting up ads, or having like in-app purchases in your games and stuff. And it's definitely a good resume booster. A lot of companies really like iOS developers. Like Apple's one of them, as well as a lot of like mobile startups. So we're going to be going over SpriteKit for this tutorial. And SpriteKit is a graphics library that makes it really easy to develop games because it's built into the Swift programming language. So it provides many useful features, such as rendering frames of animation efficiently using graphics hardware, creating physics simulations such as gravity and collisions, as well as developing complex special effects and various sprites. So let's get started. The tools you'll need for this workshop are a Mac laptop, Xcode 7 for Swift 2.0, and optionally you could have an iOS device such as like an iPhone or an iPad, and then you need to connect it to your Mac using a Lightning to USB cable. So to get started, run this line in your terminal. We're just going to clone the skeleton code repo right now, so just let me know when you guys are ready. Everyone good? Yeah, so this workshop is going to be very interactive because I feel that's the best way to learn things, just to have like your own like sample project to work through. Is everyone good now? No worries. Sorry. There. Everyone has like Xcode 7 downloaded, right?
It's a capital programming.
Oh yeah. Also, the slides are online, so like it might be faster to copy and paste like on certain things. Like, or if you need those, just let me know.
You can look at yeah, it's slides too.
Yeah, so basically the tutorial is going to be going through making your own version of Flappy Bird. So we're just going to run through like creating all the individual components of the game, starting from creating like the bird, as well as the ground, the skyline, and all the pipes. So I'm just going to walk you through the entire process. Just let me know when you guys are ready.
Something wrong.
Yeah, sorry, I should have made the repo name a bit shorter. Sorry.
American type.
Yeah, it should also be on a Google Drive link on the Facebook group if you guys made that as well. Yeah. Just let me know when you guys are good. Are you guys good?
Yeah.
Alright, cool. So the basics of SpriteKit are as follows. To import SpriteKit, you just have the import SpriteKit line at the top. So it's a lot easier to integrate SpriteKit than some of the other video game engines such as Code2D, Boxes2D. And SpriteKit's it's native to Swift, so it's not that difficult to incorporate into your game. The main disadvantage of it is it doesn't allow you to have like cross-platform games because things like Windows wouldn't let you port it to like Android, like Windows, things like that. Like other things like Xamarin as well for C#. So the basic format of creating your scene. Oh, sorry. So once you open your project in Xcode, you're going to go to the game_scene.swift file, and at the top, the general format of a scene is you have class as well as whatever your file name is, and you're gonna have it being typed SK_scene as well as SK_physics contact delegate. So basically, what this does is it enables you to have like the physics of the game incorporated into your file. So this follows the MVC principle, model view collection. Yeah, or model view controller, I'm sorry. That's MVC principle. This project actually isn't that great of an example of MVC because most of it's stored in the view. So, but in the span of an hour, it's going to be very tough to cover like more organized projects. So this is a good starting point, I would say. And as you browse through the code, you're going to see various SpriteKit variable types. You'll have like an SK_sprite node, which is basically creating like the textured images of the game, such as like you would include images of the bird, like the background, things like that, as well as just like all the images of the game. Do you guys have any questions so far? Or?
We're just loading our project.
Oh, yeah, no worries. Yeah, just let me know if you have any questions about anything. Yeah, that might be better. Are you guys okay with like the lights and stuff?
Yeah, that's fine.
Alright, so the next variable type would be SK_color, which represents the colors and sometimes the opacity of whatever the image is. So this is very common for things like the background. You're able to set whatever like background color you want, and as well as like how bright it is. So as you get a value closer to 1, you'll get the full image, and as you get closer to 0, it becomes more opaque. Like you'll be able to see through it more clearly. SK_texture handles the texture data and the graphics needed to render the image. So it's like for all the graphics parts of the game, like when it's like loading up like all the images and things like that. SK_action handles the various like like the various actions you perform in the game. SK_label node is very useful for loading things like a score or like whatever level you're on. So it basically loads the font and creates text for the display. NSInteger is the same as like a generic integer in any other programming language, but it's a special subclass file in SpriteKit used to represent the integer class. And uint32 is a 32-bit unsigned integer used to handle collisions and contact between various nodes in the game. So if, for example, the bird makes contact with like the ground or a pipe, you're going to use uint32 variable to detect the collision in the game. All right, so let's get started, guys. Are you guys? Do you guys all have Xcode open on the project?
Yeah.
All right. So let's try running the game first of all without like anything. You're going to see that for now it's just a blank generic screen. because we haven't imported anything into the game yet.
Matt, which file do you run?
So we're gonna go to gamescene.swift, and then at the top, you're gonna see a play button. Tap that, and then you'll be able to get the simulator going.
Oh,
So sorry, go ahead.
Oh no, that's fine.
Okay. Right now we can see that we just have a blank screen because nothing's been set up in the game yet. So at the bottom right, it's a very useful statistic that tells you how many nodes you have in the game, as well as the frames per second. We're not going to go into that in depth for this tutorial, but in case you're curious where that's located, it's located in GameViewController.swift, and it's in this part. skview show FPS and skview.show node count. So these are basically two Boolean variables that will show you like useful statistics, like if you want to debug your game. Like for example, if a pipe is supposed to show up but it's not, it'll indicate that at the bottom if you have like a bird, and you'll be able to count how many nodes you have on the screen.
Which file is that?
That is in GameViewController.swift.
Okay.
So following the MVC principle, that would be the C portion. So this is ideally supposed to control all the gaming logic, but in this tutorial, we're not doing that in the essence of saving time.
Okay.
Alright, so everyone good?
Where do you get this code?
Oh, it's on the Git repository. Do you have access to the slides?
I don't think so.
Okay.
Facebook.
They're posted online.
Yeah.
On Facebook.
On the Facebook?
Yeah.
Okay.
Yeah. So just git clone this one. Could you maybe like just take a picture like to make it like a more smooth transition? So just run that line in your terminal, and then you'll be able to run the project.
Okay.
Alright, so the first step of the game is setting up the bird. So basically, you can't really play the game without like having probably the most important node for now. So down here is the segment of code we need to add. Can you guys see this okay? I might want to enlarge it. Alright, so basically just copy that portion and I'll explain what each line does. So the top segment of the code is basically just assigning SK textures to various variables that we declared at the top. So the first one is going to be an image of the bird when it's stationary, and the second image, which is the third line, is going to be an image of the bird when it's like flapping its wings. So then we're going to alternate between these two in some of the code that's already been put in the project. So we don't go over this in too much depth, but that's basically just assigning the possible images for the bird. The second block of text, starting from let anim, is basically handling all the animations from here. So as you can see, you have an array of the bird texture 1 and 2. So this allows you to alternate between the two images to like show the corresponding action, and the time per frame would be 0.2 seconds. So then as you'll see, like when you start running the game, that's corresponding with the flap. And the flap variable is the one that repeats the action forever, so it's in an infinite loop and performing whatever the animation is. In this case, it's alternating between the two. Yes?
Where do you put this code?
Oh, right, I'm sorry. So the way I structured the tutorial is at the bottom, there's a portion called additional functions. You're going to paste all of them, or you're going to type it out or paste it in here. I would recommend typing it out because it's easier to like remember like certain aspects of the Swift programming language like through practice. So like as you develop like the muscle memory for it, it's like easier to retain stuff rather than just copying and pasting code.
So is it in setup bird?
Yeah, yeah. So it's ordered so that like each slide corresponds to a specific function in the game. So you're just gonna add like bits and pieces of whatever you see on the slides into the. You're just gonna fill in the function declarations over here. Right. So does anyone need more time or? Okay, sorry. So in the third segment, basically what that's doing is you're assigning a texture for the bird as well as like setting the scale resolution on the screen. And we're initially starting off like relatively in the top part of the screen. So the height is 0.6 of the original screen size. So it's going to be in the top portion, and it's going to be more towards the left because it's multiplied by 0.35. And the important thing about game development or like using SpriteKit in general, you have to add your nodes using the .addChild function. So whenever you want to actually see the bird on the screen, you have to include this last line over here. Alright, sorry, I'm being a hypocrite and just copying and pasting code, but it'll be a lot faster. So everyone good? When you try running the program, what do you see? Do you just see the bird like on the screen with a blank background? Cool.
Yeah.
So this was the first step in developing the game, like incorporating the bird node into the scene. So as you can see, it's not very exciting because you can't really tap, you can't really do anything. You just see like the bird animated with its wings flapping. So let's start to add like more features to this. And notice at the bottom, it has an additional node from before, and this is as a result of the addChild function. You basically just added the bird node to the game, so that's why we have an additional one. Cool. So next, we're going to start setting up the actual physics of the game. So an important part of any platform game is having gravity, and this is where the physics world applies. That's built into SpriteKit. So in this case, we have physicsworld.gravity, which is basically handling all the gravity components of the game. So the way this works is you have a function with two parameters, the change in x and the change in y. So we're going to have it as -5, in this case, to simulate like the real Flappy Bird. And the contact delegate self equals self line is basically enabling the game to have like a lot of like it's handling the physical interactions of the game in that line. And set up bird physics is the other function we need to implement. So basically what this does is it creates a physics body, which is a SpriteKit class, and it's setting a lot of the metadata for it. So if we're preventing it from rotating because we don't want the bird to actually rotate, dynamic is, I forgot exactly what that does. I believe it has something to do with like collisions, I think. I forgot. But the important thing is at the bottom, we have 3 lines that set the category bit mask, as well as the collision bit mask and the contact bit mask. So what the category bit mask does is, if you notice at the top, in the actual code itself, we have various bird categories separated by left shifting various attributes. So in Swift, what you can do is you can have a maximum of up to 32 various categories, and this is all determined by left shifting a various amount of bits. So in this case, we delineated it into having a bird category, a world category, pipe category, as well as score category. So this is like creating unique distinctions among each category, basically. So the category bit mask specifies which category the bird belongs to. The collision bit mask is handling what other categories the bird can collide with. So in this case, we could collide with the world category as well as the pipe category. And this is important because we want to recognize that whenever you hit those, the game's going to end. And the way it works in SpriteKit is you separate out things using a bitwise OR operator. So this is like a little nuance, and the inner implementation is done by like comparing like the bits. So we don't really need to go into that in too much detail. And yeah, the contact bit mask is basically the same. Like it's just handling when it actually contacts with each other. So did you guys have all this code set up right now?
What does the question mark mean in physics body?
What a question mark is, it means it's an optional unwrapping. So in Swift, you don't need to necessarily assign a value at compile time. So in this case, if it's a question mark, it doesn't really force unwrap a null value. If you put an exclamation one, it will force unwrap it, and this is a good way to detect like errors in your code. And I think Jahan should have went over that. All right, so is everyone good? Okay, cool. So when you run the program this time, you're going to notice that the bird is going to fall down due to the effects of gravity. Has everyone seen that when they run simulator?
Yeah.
Awesome. All right, so let's run and compile this. Sorry. It's strange. Sorry, technical difficulties. Oh, wait, no, sorry, rookie missing. My bad. Sorry, guys. As we can see, the bird is now falling due to the effects of gravity. The mistake I just made was like a really silly error, like never paste it into the did move to view function because you're just calling it in there. So, yeah. Right.
And in general, in Xcode, do you just leave the simulator sort of open at all times and then just mess with like the code, or do you like you quit simulator each time?
I would generally quit simulator each time because it hogs up like a lot of like the usage of like memory at the time, so it's gonna really slow down your computer.
Got it.
So a good shortcut for that is Command Q.
Okay.
Yeah, so it's and then just to run it's like Command R in Xcode, so it's a lot faster to run.
Oh, nice. Okay.
Yeah.
Oh yeah.
All right, so you guys ready to move to step 3?
Yeah.
Cool. All right, so as we noticed, the bird's not really moving up and down in terms of its orientation like it would in the normal Flappy Bird game. So this step is going to handle this effect. So at the top, we've already implemented the clam function in the skeleton code. Basically what this does is it prevents the bird from spinning around too much in the game world, because if we weren't going to set this limit, the bird would rotate potentially like 360 degrees, and that's not realistic to what we see in the actual game. So that's there by default. So the important piece of code is at the bottom in the update function. What this does is it sets the bird's Z rotation, which represents the Euler rotation around the vertical axis. So basically how much it can rotate from top down. And yeah, what the update function does is it's built into the SpriteKit library already. So this is why you see the override keyword before the function declaration. Since it's already been implemented, this is going to supersede whatever part of the previous definition of update was. So you're going to see the effects of your newly defined function in this case. So what this does is, it calls clamp. It sets whatever the minimum value of float is, as well as the max. So this prevents it really from rotating too much. And value is setting the vertical velocity and is multiplying it by this arbitrary factor, in order to control how much the bird rotates. All right, this one was relatively short. Do you guys need more time or anything, or no? All right. So let's paste this in. So when you run this line of code now, you'll see that the bird is going to start to rotate top down. So if you guys try running it. You can see that the bird starts to rotate downwards because it's facing the effects of the Z rotation in the update function. Cool. Does anyone have any questions so far? Or, yeah.
So you added in the little the sprite, like JPEG image or whatever, to the atlas, or where do you add in that piece?
The actual images themselves.
Yeah.
It's in the images.xc assets folder.
Okay, yeah, that's what, okay.
Yeah, oh, and it's also in the Bird Atlas. So basically, what you could do is you could create groups by right-clicking and just creating like a new folder. So basically, you can use this to like store various properties of your game, such as like images, sounds, etc. It's usually commonplace to put in an image as like images.xc assets by default, but you could also create like other new folders and just put things there. Because this just creates like a sort of a soft link. It's not an actual directory, but it's just a way of organizing it specifically within Xcode. So you know where to find all your images. Okay. So the next thing is setting up the TopRecognizer. So truth be told, this is actually not the cleanest way to do it. There's another way to do it called using a tap gesture recognizer, but this would involve going more into interface builder and using just like storyboards and connecting the interface up with that. So this is actually another way to do it, and I feel it's conceptually a lot simpler because it just uses code. So the first part is setting up the taps. So this part was needed because there were dependencies on the pipes. So we needed this segment in order to start running the rest of the code. So that's what basically this part is doing. It's setting up the moving variable as SK node and as well as the pipes. And yeah, it makes the game world appear to be moving. And the important function in this case is the touches began function. Just like update in the previous slide, it's originally derived from the SpriteKit library, so that's why we have the override keyword here, because we're essentially subclassing it and creating our own version of it. And in the parameters, you have a set UI touch, which is basically handling the tap action with your screen. And with event is handling like whatever the UI event is. In this case, it would be just whatever you set it to. Like in this case, you want the bird to like physically jump up, and this is handled in this part. This segment is the one that handles most of the bulk of the code for creating the action when you tap the screen. This is what's basically causing the bird to jump up. So it's checking if the bird is actually moving first of all. And we have a for loop inside that recognizes any touch to the screen. So it first checks where the exact location of the touch is, and then it applies the impulse, which is basically the action that causes it to jump up vertically. So you see the change in X and change in Y here. Since Flappy Bird is mostly an up and down game, that's the reason why we only have a change in Y. And it's set to an arbitrary 30 because that's a fairly reasonable jump factor. And what this bottom line does, it was originally included in the code, so don't worry too much about it. But if you look at the top, we have a variable called canRestart, and it's initially set to false. So it's not going to go through in this case. But if later on when we implement the restart part of the game, then it's going to let you basically restart the game whenever it finishes. Alright, so is everyone good now? Alright, so let's add in this portion. So this is the part when you really want to try to connect to your iOS device because it's a lot more fun than working with Simulator. So if you guys need time to do that, just let me know. But you can still do it on Simulator, but the effect isn't really the same. Alright, so try running this now. There's a warning here because we don't really use the let variable. So then this is actually bad practice, but I think it was supposed to be used later on, but it's fine. So when you run the code, if you tap the screen for either your iOS device as well as Simulator, you'll notice that the bird actually starts jumping. So, are you guys seeing that? Or? Oh, cool.
How do you is there a way to quickly get to work? What did you say about the phone? Plug it in?
Oh yeah. Yeah, so you would connect it using your USB to Lightning cable.
Yeah.
So then in Xcode 7, there's a new feature that lets you upload your game onto your iOS device without having to have a developer account. So before Xcode 7 and pre-Swift 2.0, you would have to get like a $100 developer account just in order to run your iOS device, which is honestly kind of lame. But then this is enabling more iOS developers to just like play test their apps before they buy a developer account to release to the App Store. So as we can see, the bird is, sorry, let's restart this. As you can see, you can now control the taps, or the amount the bird jumps just by tapping the screen. Yeah, so for specifically running it on your iOS device, you'll notice at the top over here, you will see the various types of devices that you can connect. In this case, I haven't connected anything yet, but if I were to connect it to my phone, you would see a new image, or sorry, a new device added that you could compile your code on. Okay, so now you can see that private photos. Don't look. So now you can see that we've added a new device. In this case, my phone. The reason it says OS version lower than deployment target is because this is essentially running it on the most recent version of Xcode. And in case you're curious on how to control that, you basically go to this top left portion at the top of the view hierarchy, which is basically your project name, and you would go to here, deployment target, and specify whatever it is. In this case, I don't have iOS 9.2, so I would set it to like an earlier version, like 9.0 or whatever, and the error goes away because that's my phone's operating system. So if you just try running it on your phone now, you're going to be able to see like the results of the game, and then play test it through an actual iOS device. All right. So everyone good? Cool. So the next step is creating the ground. Basically, just having a bird like floating around by itself without like anything is kind of boring. So this is where we add more nodes to the game. So in the function create ground, we have filtering mode equals .nearest, which I didn't happen to explain earlier, but what this does is it means each pixel is drawn to the nearest point in the texture. It's more of a stylistic thing. It's not really that important in the grand context of like the actual gameplay, but it's more for just like the UI and stuff. The next segment of code is controlling your X distance that you move by. So it's the horizontal distance of the game. And we've set it to whatever the ground texture width is, and it's the same like principle as like some of the other ones. The first parameter is this, and it's handling how much you're moving in terms of like your X and Y. And the next part is like the duration of your time duration of how long it takes. Reset ground sprite is going to basically reset the game like whenever like the lives are over. Yeah, like whenever, or basically when the game restarts, it just like resets like the ground's action. And move sprites forever is what we did earlier in terms of like repeating like the action. This is what causes the ground to move continuously throughout the game. And this is done through this for loop, which handles like all the interactions of like the ground actually moving. So as you can see, we're just adding another child again like we did earlier. So were you guys able to get like all this part? Alright. So if we were to run this now, you'll see that the ground is actually created. But as we can see, when I run it, there's no interaction yet because we haven't set the bit masks or any of the things with the game. See, it actually goes through the ground because we haven't specified what happens when there's like contact between the ground. So in this case, we need to add more interaction here. And we can also see that we've added like another node if we go back up. You can see that there are 3 nodes now. Like initially it was 4 for some reason. But yeah, in this case we've added the ground node. So then that's what's accounting for the additional one. Any questions about like the ground node that we've added so far? Or, okay. So now we're gonna actually handle interaction with the ground and the bird together. So in the function create ground interaction, what this is doing is you need to set a ground texture in this case, unlike the previous ones, because this is for handling like the actual texture of how the UI looks here. So basically what this is doing is it initializes your physics body of the ground to create the physical dimensions. So this is done in this 3rd line over here that I've highlighted. What this does is it creates a physics body using like an initializer. And it's a rectangle of like whatever arbitrary size we set. So in this case, it's the entire width of your screen, as well as the height would be for the ground texture, which we've set in another part of the code. Dynamic is false again, like just like in the bird. And this time we've set the category bit mask to the world category. So this is going to actually like create the interaction with the bird, because if we go back to what we did previously, we have the contact test bit mask set to handle like a world category interaction. So in this case now, when we compile this code, we're going to see that the bird isn't going to go through the ground like it was before. Alright, did everyone have time to put in all the code? Alright, so when you run this, you're going to notice that now the bird's not going to go through. So basically, as soon as it makes contact with the ground, it stops because of the contact bit mask that we've set in the bird function. And I have a warning here because I never actually mutate the ground, so I could set it to just like a constant using let. So that's what this warning is saying. Alright, so the next part is creating the actual skyline of the game, so the background that you see in the real Flappy Bird. It's very similar to the ground because the skyline moves alongside the ground in the X direction, and Z position is the height of the skyline node relative to its parent. So the way the game is structured in SpriteKit is using a tree-like structure. So initially your root is going to be like your game scene, and then you're adding like individual nodes to like as the children. So like the bird would have been a node, the ground, as well as the skyline. These are all the children nodes of your original game scene. So what this is doing is creating the texture from the sky image, which is in the XC assets folder. And this segment of code is basically doing the same thing. It's moving in the X direction and just handling like the interaction of when we're resetting the game. And the for loop, it's a very similar principle to what we were doing in the ground interaction. So we're just setting various features of the movement. So such as like the Z position, which is the more of the vertical part of the game, the actual position, which handles like the relative X and Y locations, and it's running the action forever and adding it to the game. Are there any questions on this part? Alright, so let's run this now. So as you can see, like when it runs, like you will see the skyline of the game. So this was an imported image in the XC assets folder over here. So there wasn't really like any fancy like graphic styling using like OpenGL or WebGL, but yeah, this is like a very generic way of like attaching like images, but there are more advanced ways to do it. I'm just not sure how myself though. But yeah, there's a lot more things you can do. For example, in this gamescene.sks file, you would be able to add like various things like sprites, lights, etc. But we're not going to go into that for the context of this tutorial. Alright, so now let's create the pipes, because otherwise we wouldn't really be able to play the Flappy Bird that we know. Alright, so what this is doing is, the thing we need to know beforehand is that I've included a spawn pipes file originally in the skeleton code way at the bottom. So this is handling the creation of the pipes. It was a bit complicated to work with, so that's why I didn't add this part as part of the tutorial. So let's just assume it works like as like a black box for now. So it's like the same principles here. You're creating the pipe textures as well as handling how it's oriented. This segment of the code is actually spawning the pipes. So it's calling the spawn pipes function in the variable declaration for spawn, and you're running the action over here. So you have the spawn, then delay variable, which has like a sequence, so it alternates between the pipes being created as well as the intermediate period when you're not creating anything. So that's what this part is doing. And this bottom segment is randomly, no it's not, sorry. What this part is doing is creating the pipes the way it's moving around, like the amount of distance that the pipe spans on the actual game screen. Alright. So is everyone good on this part? Alright, so let's run this. You will actually see the pipes appearing on your screen. So it's a little bit more like the real Flappy Bird. So now you would see the pipes here, but we don't have the physical interactions yet, like originally that we had for the ground. And the reason for this is because we haven't specified how we want the bird to interact with the pipes. So you have bugs like this because we simply haven't implemented that feature yet. So, but we'll get to that. Alright, so the next thing that we're going to go over is setting up the background color. The reason we're doing this before actually handling the interaction between the bird and the pipes is because there's a dependency on one of the variables. So then I had to do this part first. But it's a good it's a good side step in order to figure out like how background colors work for a lot of images. So for SK color, you have an initializer that takes 4 arguments. So you have the red, green, blue aspects, as well as the alpha that we were mentioning earlier. So red, green, blue have weights from 0 to 1, and a common practice to set your color is to have a ratio over 255 to create your color scheme. And alpha is a measure of the opacity from 0 to 1, and the way it's defined in SpriteKit is that 1.0 is completely visible, whereas 0.0 would be completely invisible. So this is a very, very short line of code, but it's important for setting up the rest of the dependencies. So let's add this in. Alright, so I'm sure everyone has that already by now. So let's run this. Basically sets more of a background color, because like previously before this is kind of bland, it didn't have like the blue that you would see in the actual game. So that's what that part's basically doing. But we still haven't had the interactions with the pipes yet. So let's handle that. Let's close this first. So now, step 10 is setting up the remaining collision bit masks. So like earlier, we're using, in this case, we're handling the collisions between two of the nodes. So what this is saying is did begin contact has a SK physics contact, which is handling the actual physical interactions in the game. And as the bird is moving, you're going to recognize like a contact between body A and body B. So this is sort of arbitrary right now because it doesn't look in terms of like it's not strictly determined what body A or body B is. So like it's bidirectional. So body A could be considered the bird, and body B could be considered as like the ground or the pipe, and vice versa. Which is why we have the OR statement here, and you're just checking whatever category it is. So in this case, it's actually dealing with the score entity, which we haven't dealt with yet, but we're going to get to that. And the same principle applies below. This is adding physical visual feedback for like incrementing score, which we'll see later. You'll see that sort of the label like sort of pops out, and that's what that part's doing. The run action function is handling like how much the bird rotates by, and this code is the one that actually deals with like what happens when the game is over. Like you'll see a flash of red light. This is basically what this action is doing. This part's a little bit more convoluted, and I didn't fully understand the working details myself, but this is basically what happens when you when the game finishes, like when you collide with something. You're gonna remove an action which is gonna cause like the flash of red light, and it's waiting for the game to be able to restart. So this part's a little tricky, but we're just gonna go through this part for now. This is the function that handles the interactions though and the collisions. So it's quite a bit of code. So let me know when you guys are ready. Is everyone good? Anyone need more time? No. You guys are good? Yeah. All right, awesome. Alright, so now when we run this, we'll notice that you can actually lose at this game now. Like so, let's say we hit the ground, boom, you can't do anything anymore because of this part. The else statement is the one that actually handles the interactions. So I was a little unclear about this part, but what this does is whenever it doesn't detect this first if condition, which is dealing with like each time you pass through a pipe, you increment the score, it's gonna go into the else statement. So this tells you that you've made contact with either the ground or the pipes. So we could have like been more specific and said like we would have like the category bitmask comparing like the bird category with the world, but in this case it's a lot easier to just do it in the else statement. So that's where that's coming from. So as you can see, if you tried running this part, you can't really interact with the game anymore. So that's where we're going to have the reset scene come in. And we will also see the same effect if we collide with like a pipe. So it isn't just the ground in this case. If you collide with the pipe, you will also lose the game. So that's that part.
Alright, thank you.
Yeah, thank you. Alright, so the next step is setting up the score. So in this case, the SK label node initializer passes in the font type. So for Xcode, there are various types of fonts that you can use to assign to your score labels. This is just one of them, marker felt dash wide. But there are various options that you can pick. Probably like the generic ones like Arial, but I haven't really worked too much with that. And yeah, we're basically just setting up the position for the X and Y coordinates of the node. And Z position is the height of the score node relative to the parent like we did in one of the previous examples. So this is setting it up like more towards the upper part of the screen, like right in the center of the top half, because it's 3/4 of the frame height. Alright, so are you guys good with this part? Yeah. Awesome. Alright. So let's add this in. Now you could actually keep track of your score as you're playing the game. So when we run this, we will, there we go. It's a bit of a bigger screen. So we're going to see that we have like the score implemented. I'm not very good at this, so I didn't increment, so let's try it again. Hopefully I can actually score this time. Oh my gosh. let's hack this game. Let's make it easier. Alright, just for demo purposes, I'm gonna make the gravity have a very strong effect. There we go. So it's not bounce or jumping around very much. So hopefully I can score now. Oh my god, I'm so bad.
Can you make the pipes like less?
That's a bit harder because I randomly I did a random generator in the spawn pipes, but in the context of saving time, like I don't want to go through it too much. But if you guys try to play the game itself, you will see that it increments. I'm sorry, I'm very bad at this. Alright, so the next part is finally resetting the scene. So this is the last part. So this enables you to actually restart the game because as we saw previously, you wouldn't be able to tap on the screen anymore after once you lose. So this is a very important feature. If we notice for the collision bit masks over here, we're using bitwise OR like we did earlier to specify that you can collide with either the ground or the pipe. And the way it restarts, it's not very SpriteKit specific. It's basically just using a boolean, which is the can restart variable, and it's setting it over here and just like restarting the game. So it's not really doing anything fancy. This is an important line because it removes all the existing pipes in the game, so it allows you to essentially restart. So is everyone good on this part? All right. So this is the final part of the tutorial. Once we have this added in, you're going to be able to restart the game. So hopefully I can try to score this time. Oh my god, I'm so bad. How is that possible? Oh my god. Alright, but as you can see, like you're able to restart now. Hopefully I'll be able to score at least one. Yes! Yeah. Yes!
You're on a streak now.
Oh man. Alright, there we go. Alright, so that's the end of the tutorial. The complete repo is on this link if you guys weren't able to complete it. This is originally from Fullstack.io, so I'm going to give credit to them. But their original repo doesn't really have the code modularized. So in terms of learning, this repo itself is a lot easier to like learn from because you're able to subdivide each component of the code. So yeah. Yeah, thank you guys for coming out.
Yeah, man.
Thank you so much.
Yeah.
If you have any feedback, just like let me know like what could be improved next time. Like just like if you enjoyed it, just let me know.
You're perfect, Matt.